All right, so in assignment number 7, we're going to be talking about the law of sines. This is something that you've already really done in geometry, but we're going to review. We're going to talk about why it works and then how to use it. So let's go ahead and get started. We're going to develop the law of sines by looking at the area of a triangle in a different way. Suppose we know the two sides and the included angle of a triangle, and we want to find the area of the triangle. Well, we know that the area of a triangle is 1/2 the base times the height, but right now we don't know what the height is. But if we take a look at this triangle here, we can come up with a relationship for the height. We know that the sine of C, the sine is the opposite side over the hypotenuse. So the sine of C, in this case 65 degrees, is going to equal the hypotenuse, or h, over A, which is this side here. And so if we rewrite this by multiplying both sides by A, then these A's will cancel, and I will have that h by itself on the right hand side, h is equal to A times the sine of C. And so if we plug that into our formula for the area of a triangle, we have the area is equal to 1/2 times the base times h, but h is A times the sine of angle C. And so that means that the area of this triangle can be represented by the expression 1/2 B times A times the sine of C. So we can switch these letters around. It might make more sense if we write it like this. It's 1/2 AB, if I put it in alphabetical order, AB, and then times the sine of C. Well, how does that help us? Let's go ahead and take a look at this again in a different way. Here we have the original equation that we came up with. The area of this triangle is equal to 1/2 A times B times the sine of C. That's if I use those three sides, or those two sides, and the included angle. Well, if I use B and C, that's this side and their included angle, I can say that the area of the triangle is equal to 1/2 BC times the sine of A. It's always the included angle. And if I use these two as my sides and their included angle, I could say that the area is equal to 1/2 A times C times the sine of B. Well, if I get rid of the area, I know that all of these are equal to each other. What I'm going to do is multiply all of them by 2. And so if I multiply all of them by 2, the 1/2s will cancel. I'm going to get a different colored pen here. So then I'll have AB times the sine of C. That equals BC times the sine of A. And that equals AC times the sine of B. Those all have to be equal to each other. But what I'm going to do is divide all three of these sides by ABC. And we're going to have some things cancel out. Like, for example, in the first terms, it's the A and the B. And I will have the sine of C over C. In the second expression, I'll have the B's canceling each other out and the C's canceling each other out. And it'll be the sine of A over A. And then in the third expression, I'll have the A's canceling each other out and the C's canceling each other out. And I'll have the sine of B over B. That leads us to this expression. The sine of C over C is equal to the sine of A over A, which is equal to the sine of B over B. And so how that works is like this. Let's just take a look at a problem like this. Normally, we wouldn't be able to find the value of x, because in order to find the value of x, we'd either need a right triangle to use our trig functions, but now we don't need the right triangle. We can just find the value of x by taking a look at the sides opposite this. So for example, I'm going to first find this angle. We know that the angles in a triangle add up to 180. 20 and 15 add up to 35. And so if I take 180 and I subtract 35, that's going to be, what is that, 145. So if I let this be my big A and this is my little a, and I let this angle here be the big B and this is my little b, I can use the law of sines. I know that the sine of A over A equals the sine of B over B. And so that means that the sine of 145 degrees over x, that has to be equal to the sine of 15 degrees, that's a S, the sine of 15 degrees over 7.5. And so I'm going to cross multiply here. If I take 7.5 times the sine of 145 degrees, that's really close to 4.3. And that equals x times the sine of 15. And the sine of 15 degrees is 0.259. 88 to be exact, but we'll say 2.259. So then I'm going to divide both sides. I'm going to divide both sides by 0.259. Divide this side by 0.259, and I'll have that x equals 4.3 divided by 0.25. I'm going to use 88 because I know that's a little bit closer, and that's 16.615. 16.615. So that means the value of x has to be 16.615. And I wouldn't have been able to do that without the law of sines. Let's take a look at another example. So suppose I want to figure out the value of A. How far away is this plane from that radar? And so I have these two angles, 15 degrees and 35 degrees. I know that the 35 degrees is opposite A. I'm going to need to figure out this angle here, because it would be the angle opposite my 20 miles, which is the distance that I do know. I know that 15 plus 35 is 50, and so 180 minus 50 is 130. And so I can set this up by taking the sine of 130 degrees over its opposite side, which is 20, equals the sine of 35 degrees over its opposite side, which is A. And so again, I'll cross multiply. I'm going to take 20 times the sine of 35 degrees, and that's 11.47. 11.47 equals A times the sine of 130. So A times the sine of 130, and the sine of 130 degrees is 0.766. So then to figure out what A is, I'm going to divide both sides by 0.766. These 0.766s will cancel, and I'll end up with A equals 11.47 divided by 0.766 is 14.97. So that must be 14.97 miles. And that's the value of A. Let's try one more together before you are able to go do your homework assignment. I want to find beta, the measure of this angle. So this is a little bit different because the other two I was missing a side length, and this time I'm missing an angle measure. But I do know this. I do know that the sine of 35 degrees over its opposite side, which is 6, is equal to the sine of beta over its opposite side, which is 8. And so I'm going to go ahead and cross multiply. 8 times the sine of 35 degrees is equal to 4.59. And that equals 6 times the sine, that's the sine of beta. Well, I'm going to divide the 4.59 divided by 6. That gives me 0.765. 0.765 equals the sine of beta. Well, then I want to figure out what beta is. So I'm going to do the inverse sine. And so I'm going to take the inverse sine of 0.765. And that gives me a value of 49.9, which means that beta has to be, I'm going to round it to 50 degrees. That's the kind of thing that we're going to be doing with the law of sines. The law of sines by itself is simply the sine of A over A equals the sine of B over B equals the sine of C over C. Good luck on your homework, and we will see you tomorrow in class.